see if I can share this. Looks like it's working. Whenever we look at arrays, we're looking at a collection. And a collection in C# is just any time we have a whole group of something. So an array is just one way we can save a collection in C#. And it's the most basic way, like the least functional, right? So it's closest to the machine. Whenever we create an array, we're basically creating a structure that holds repeating data. So I can have multiple instances of something. And an array lets us save information more efficiently than having a bunch of variables. So if I wanted to keep track of a bunch of test scores, I could ask a user, what is score 1? And I could save that in variable score 1. And I could ask them, what is score 2? And save it in variable score 2. And I could keep going, and I could have score 1 through score 9 as variables, and I could refer to each of those individually, but it would be really time-consuming and clunky code. And I could use an array instead to hold all of those values more efficiently in basically one variable or one object in my array. Now, when I use an array, I have to allocate it before I can put any data into it. So I have to tell the system how big it's going to be. And when I create an array, one thing that I have to be aware of with C# is with a basic array, all of the entries in the array have to be the same data type. So I can have a whole bunch of ints or a whole bunch of doubles, or like we were working on in one of our assignments, a whole bunch of phones or a whole bunch of whatever data type things I want to keep in my array. Now, another limitation to basic arrays when we're working with C# is once they're allocated, we can't change their size. So they are not dynamic at all. They're just very, very fixed. So that's a few little, yes, sir?
Unlike in Python.
Right, so they're not dynamic like that. And that's one of the areas where we save on performance, right? So when we have a dynamic array like that, where we can change size and move around and be super flexible, that's a lot of overhead. The system is taking care of all of that happening for us, which is great, but we know we're going to have some overhead going on with that. Whenever we're working with C#, and this is all very fixed, we know that we are being as resource conservative as possible because we're going to handle all of that stuff ourselves. So it's going to be a little bit more trouble for us, but a little bit performance improvement. We'll see, though, in C# we do have other data structures besides a basic array that give us some of those advanced capabilities. It's all a performance trade-off. You know, do we want some of those things to happen dynamically, like the size of the array to increase or decrease, or are we going to take care of it ourselves and have that performance? So it's an option.
What you're making, really.
Yeah, and it just gives us the choice. So with a basic array, we can't change that size. So think about your data and your variables. Here we have a double that's holding a value of 25, an integer named age, a string named Joe, or has the value Joe and the name, a decimal variable named payment that has that $123 value. We have a Boolean variable with a true value. So each of these are individual variables that can contain, talk right, a piece of data. With an array, we can have a whole collection. So here, I can use syntax in C# to say, I want to create an array of strings. So here is the array that gets created. Now notice I have it going up and down in the picture. We could also think of it going across, you know, stacked right beside each other. Either way, no matter how you conceptualize it in your mind, that's going to be contiguous memory. What's contiguous mean? It's going to be broken up, and I have a piece of it here, a piece of it there, a piece of it over here.
So like you can select it whatever you want.
Nope. What do you think, Randy? What's contiguous? Good thought there. Yes, it's all together. There is no breaking. It's not scattered around. Like on your hard drive, this file might be in 500 different places and it gets all put together. That maximizes that storage capability. An array is not like that in C#. It has to be contiguous in memory. So that means if I make my array size 50,000, I have to have that much memory available contiguously on that machine. Whatever 50,000 things of that type take up. So that can be another constraint. We have to be aware that that can happen. And again, we have other constructs that we can use to take advantage or to do better than that, but we'll lose some of that performance. So here is our first array. We created an array, and let's look at some of the things about that syntax. First of all, we started out with our data type of string, but then right after our data type, we have the open and close square brackets. And the open and close square brackets are what tells C# this is an array. And so they're keywords, basically. They have meaning. They mean this is an array of whatever this data type is, so strings. Now, whenever we're working with an array, we have all of these entries in our array. In this case, we have these 5 strings, Joe, Bill, Tammy, Vera, and Austin. Well, to get to a specific string, we use an index, which is just a pointer into our array to tell us which entry we're looking at. So in this picture here, we have the index value beside the data value that's held in that array. So if I want to look at my name array, index location 3, I'm going to see the data for Vera. Okay. Our index value, our pointer into our array when we're working with an array, always begins with 0. So we always start counting at 0. And that's a good programmer joke, you know, because we always have to start at 0. Sometimes when you're a programmer, you get those things, and other times you don't. Once, when I used to take care of the database, sometimes on the system that we worked on, we had to work in hexadecimal, base 16 values. And we had to start with 0. And there were certain things that I had to do that were pretty technical as far as updating code in specific locations. And I had this patch, this update that I couldn't get to work. And no matter what I tried, it just kept rejecting, saying it wouldn't work. And I went to the systems programmer, another person there that worked with me, and asked him what the problem was. And he said, I don't know, let's count it out. And he just started looking at it, and he said, 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, because then he started counting in hex, and I was like, I was not counting in hexadecimal. I was counting in decimal, so I was not in the right location. So we have little weird things like that when we're software developers to help us get paid extra, right? We like it. Starting at 0 is one of them. That's how we get that off by 1 error, because sometimes we want to display the value of the index. Sometimes we want to display the value of the index +1, depending on what we're looking at. So here's Tammy. She is in position index location 2 of our array. So I could refer to her variable name, basically, is the array name followed by the square brackets with that index value. So name square brackets 2 would be this index location 2 of our array that has that value, Tammy. So just like a variable, no different. It's just that we have to put the square brackets with the index location to indicate the pointer within our array that we're working with. In this example, if we want to update the name in index location 2 of our array to a value of new name, we would just use this syntax. Name at index location 2 equals whatever this new value is. So just like any other variable, if we want to set it to a new value, we can just name it like that and set it to a new value, and then it's going to update in memory in our array. Now, some other things about this before we go on. Let's take a look at that syntax. First of all, when we create an array, we specify in C# the data type, followed by the square brackets, open and close. We don't put anything inside of those square brackets when we're declaring the array. Then we have the name of the array. That's all we need. We can stop at that point, and that would be our basic array declaration. I'm going to have an array of strings, and it's going to be called name. Now at that point, C# doesn't know how big it is. It's not allocated in memory. It just knows that it's going to be. Now when I use the new keyword, I'm saying now allocate that array in memory. Make it a new array in memory and make it of strings, and I want 5 of them. So whenever I actually allocate that array in memory is when I'm specifying how many entries I'm going to have in the array. So when you first look at that syntax, it seems kind of weird. It seems like you have to duplicate the open and close square brackets at the beginning of the statement and the end, and you sort of do. But if you think about it as the fact that at the beginning you're saying this is my data type, and at the end you're saying, you know, how big do you want this overall collection to be? What's your collection comprised of? So I can set up my array however I want. Here I have an integer that's set to 5. And here's my array of integers. Instead of just having one age integer, now I have an array of integers named age. Now this is an optional syntax. And in this syntax, I told C# I want an array of integers. So I use the int keyword with the open and close square brackets, and I want it to be named age. And here are the entries that I want in that array. So if I use opening and closing curly braces, I can just specify a list of entries to initialize that array. So if we look at this array now, as soon as this line of code runs, we have this array allocated in memory named age. Index position 0 of the array has the value 16. Index position 1 of the array has the value 45, etc. It's just allocated it out, put those values into each slot just the way we asked it to. Now again, it's contiguous memory. It's all together. Our index position is our pointer into our array, and it helps us access that value, that data that we're containing in our array. So here's one. Let's code it. Go ahead and open Visual Studio, and let's create a new project. I'll let you do it. And make a console project. And let's just put these few lines of code in our main.
You do a minor rate practice.
Yeah, array practice is a good one. I would say chapter 4, but our chapters are so meaningless. I'm sorry, it gets me all whacked. Could say week 9. That's what we should be doing, huh? We'll get more organized at the end. one.
Don't forget to add the constant statement.
Yeah. According to the comments, that last right line is going to cause an exception. Does it cause an exception? What's it upset about? Our range, what would our range be of our index for that array?
0 through
0 to
4,
4?
even though we say 5 because computers start at 0.
Since it starts at 0?
Yeah.
So let's make it print out 3. Age sub 3. And fix that problem. Does it work?
I don't know. What that read line?
Oh, that's what you read.
Yeah, that's what I meant.
So with that index out of range exception, that's a common exception that we're going to see when we work with arrays. We're going to get used to it. Shouldn't be a problem. So looking at that code, what is the identifier or the name of our array?
Would that be age?
Age. Is that right? Got it. And what's its data type?
Integer?
Integer. And then you guys already explored how many entries we can have in our array. So hang on to that code. We'll come back to it. Now, if you want to put any comments in there, in your array declaration, remember this line of code declares our array with this first part, and then it allocates our array with these values. So it basically does both parts. Yes, sir?
When I type it into Visual Studio, it automatically removes the spaces at the front and end.
Does it with your curly braces?
Yeah.
It doesn't like those spaces. So that's okay.
As well as in the right line, it removes it.
I don't know if that's something that's changed, but it definitely doesn't like all those extra spaces, which is okay. Okay, so we got our unhandled exception on that one. Anytime you want to take a look at that, you can create that exception really easily in this code and just put that index value to an illegal value. Let's make it be -1. What happens if you run that with your index value set to -1 here?
Wouldn't that be out of range?
Yep. System.index out of range exception.
When you look at Visual Studio, can you find what the value of your index variable is on that exception?
Yeah.
So you'd be able to find and track down that bug. Those ones can be hard to figure out. Good, so we know that's a common thing. So this is our array within initialization. I can say it correctly. We have our data type followed by our square brackets, our identifier or name of the array, and then our initial values separated by commas within curly braces. The system, as you saw, used those initial values to determine the size of the array. So we couldn't have added anything else to the array when we do things that way. That's that fixed size, basically. Now, this next example shows you that you could create a variable named age and set it equal to one of the index entries in our array. So just kind of some example syntax for you, because sometimes we can have to search for those kinds of things. Here's another one where we want to update the value in the array. We want to set index location 2 in our age array to a value of 28. We have our array name followed by our index pointer within the square brackets. And then after our equal sign, what we want our new value to be set to. And then we should see our new value. Okay, so let's add this loop to the code that you guys have. So in this for loop, we're going to use the length variable. And there should not be that space there. It'll probably get rid of it for you. But whenever we use an array, like our age array here, we're creating an instance of the C# array class. And just like a class that we create, the C# array class has methods and properties that we can use to find out information and set information about our array. And one property we have is the length property. So when we say array name dot length, we're going to access that length property of the array to find out how big our array is. So we're going to use that length property to control our for loop, to write out each entry. So let's put that for loop in and run it. Make sure you have your read key or read after it, not in it. You can see how it works.
The name ages does not exist in the current
Age, not ages.
Oh, yep, typo.
It prints out all of them
Got them all.
in order.
So we can use a loop to control that kind of thing super easily, and we'll get a lot more practice with looping when we're working with arrays. And then we see that we have that property, that length property, that we can use to figure out how big an array is. So if we need to know that value, we can. We might not have declared this array. It might be being passed to us as a parameter. So we might need to use the length property to find out how big it is. Okay, so add some comments to your code about that loop, whatever you need to say for it to be meaningful to you. So we're just using that I variable to loop through our array. And you'll hear people, programmers, talk that way. They would say walk the array, loop through the array, because we do that so often. You can also hear the fancy traverse the array. Yes, sir?
Why, how come in for loops, like in those C# and Python, by default are typically associated with I as their variable?
It's just kind of how things have evolved. So you can make it be whatever you wanted. It's just that people use I real commonly. And so we've gotten used to seeing it in a line of code like this. And we know I is probably the index that's being looped through.
So if I was running two different arrays and I wanted one array to be done in a for loop and then another one, I could use T instead of I.
Oh, for sure.
Okay.
And you could make them long if you wanted to. You know, you could make it array 1 index,
Okay.
and array 2 index, whatever you wanted to in your for loop. Yes, sir?
I was going to say, you're going to see that used in JavaScript as well.
Yeah, just kind of evolved into a way people do it.
So it's just sort of an informal convention.
Yeah, it's not really a standard or anything, just kind of has evolved. And so it's gotten accepted because even though we don't like just one letter variable names, in this kind of case, it's everybody's used to it. It quit working. Oh, you meanie. Okay, look, it's shaking. I didn't realize the PowerPoint was doing it. I thought it had died. It's showing you each of the entries. Oops, shake, shake, shake. There you go. Okay, and it prints out. All right, what about this one? Now, the reason that last PowerPoint slide was showing you each thing, let me go back because, you know, it's just so awesome. Will it work? Oh, I'm almost there. Okay, so in our for loop here, we start out with our value of I at 0. And the first time we go through our for loop then, we look at that first entry in our array. That's why it's shaking. See it shake? So that way, we're just looking at that one. But notice, if you would, in this picture, one thing that's really important is all the other ones are available. I mean, if I wanted to look at I plus 4, I could. Well, I would be too far out of the array. I plus 3, I could. It's available, right? I can see it when I'm using this for loop. This is an important point. Now, in my next execution, I becomes 1. I look at that value, 45. Then I becomes 2. I look at the value 29 and print it out. I becomes 3. I look at 24. And as I'm looping through this array or traversing the array, I can see any entry I want to in the array. I'm just focused on that entry that's pointed to by my index value I, okay? Now, why that's important? Well, we also have an option to use what's called a for each loop. And a for each loop is super handy. And it's a great way to do things. So let's put that loop in your code. And in this one, we want to use a for each loop to write out all of the entries in our array.
Does the same thing.
Does the same thing. That's why we had to go back and link that PowerPoint, because it looks like it does the same thing, right? Are you getting your same output for each loop? Now, what's different though? It is different. When we do a for each loop, we have some interesting syntax here. Within our parentheses, we specify what each thing is. So in this for each loop, we're saying, look at the age array. Each of the entries in the age array is an integer, and I would like to refer to it as entry as I go through this for each loop. So when I begin the for each loop, I'm specifying all those things. I'm saying the collection I want to look at is this age array. It has to be a collection for a for each loop. And each thing in it is an int. Now, as I go through this for each loop, the first entry, click. I wonder how close I have to be. Oops, I have to be on the right thing. I'm clicking on emails here. Let's see. There it goes. Now, for each time I go through the for each loop, I'm going to be looking at one particular entry. So my first execution, my first iteration of that for each loop, I'm going to see the 16. That's going to be entry. Entry is going to become 16. The next iteration of my for each loop, I'm going to be looking at the entry 45 and printing it out. Can I see 16 anymore?
No.
No. Not as part of my for each loop. Now I could branch off somewhere and say, looking at the age array subscript 0, what is that value? But my for each loop itself is not exposing that data to me, if you notice. It's only exposing the one entry that we're looking at currently. The next iteration of my for each loop is going to give me the 29 to work with. And then I'll get the 24. And finally, the 14. So my for each loop is great, and it's fantastic syntax. And it's definitely what we want to do to iterate through a loop like this, or an array like this, but it's read-only. So I can't be updating things in my array when I'm using a for each loop. And within the for each loop structure on its own, I'm only accessing that one individual entry at a time. So notice how that's a little bit different. We can always handle it, but it is a little bit different. So our for each syntax overall, for each is our keyword. Then we have our criteria within parentheses. The in is a required keyword. Within our criteria, we have the data type of each of our collection entries, the name of a variable to hold each of those entries, and the name of our collection or array. So take control of it, get a handle on it, Don't be one of those people saying, I don't know, does it want this thing here? I don't know, does it want this thing here? It's a lot easier to code if you know what it wants where. Okay, so we have some practice assignments on REPL for array processing. They're kind of like the ones that were for subprograms. They're pretty specific about creating things, so they should go pretty quick like that one did. There's lots of samples. Okay, some other concepts that we need to worry about though. What if we need to keep track of something associated with something else? Like in this example, yes sir?
We use a parallel array?
Parallel array would be great. Here we want to keep track of like an employee ID and their name. So we could have two arrays working together side by side to keep track of all of this information.
I just realized the title says.
Yeah, you're good. He's got it. Now, whenever I look at this though, and I see this parallel array, this is a great concept. But we saw that with classes, with C# with classes, we could actually make each entry in our array a whole instance of one of our class objects. So we can go a lot further than just parallel arrays, even with our limited array capability. So here in this example, index value 4 would refer to Austin and the ID of 14. So we would use that same index value to refer to both arrays, giving us that data that's being kept in parallel, keeping it together. Now, whenever we're working with parallel arrays like that, it is that index value that's making them be related. Now, whenever we worked with modules and setting up methods for the first time in C#, again, it can be a concept that's a little bit confusing at first, and as you work with it, it gets to be something that's not that big of a deal. Whenever we pass data from one method to another, when we're using C#, we pass it as parameters. So let's look at this main method here. It sets up an integer and a double, and then it creates a new integer to hold the value returned by this method update int. This method update int expects a parameter of an integer and a parameter of a double. So we use our integer and double variables to supply those parameters. Now, whenever we do anything within this method, num and multi are never affected. Right, in this code they wouldn't be because we didn't affect them. But even if we tried to change their values, when we got back to our main method, our values would be unchanged. That's because these values are being passed by val. That means that when the runtime system goes to execute our update int method, it says, oh, here's this main method passing an argument with a value of 12. I'm going to copy that value into this update int's memory so that it has its own copy of that number 12. And then for a double, again, I'm going to copy that value. So now these values are really held within memory 2 times, right? One value here for a double for our main method, and one value here for multi for our update int method. Now when we return our value, it gets returned, everything's happy, it does that output just like normal. So this is passing by value. This is how we normally pass things. We do it all the time. You guys have got to be experts at it. But there are other ways, and there are other ways that some textbooks and different things have just kind of implied to you, but maybe not as much as you would like. We can finally actually do some examples now. When we're working with arrays in C#, if we did that passing by value, and we had an array that had 50,000 entries, and we made a whole copy of it, then we would be making a duplicate of this huge array that has 50,000 entries. So when we're working with arrays, we can use huge amounts of memory very easily. So because of that, arrays are always passed by reference. So that means that instead of passing a whole copy of the array, I'm going to be passing the address, the reference of that array in memory. So here, I've got some code. Let's look at our code over here. We set up an integer arrays. We call our update int method, passing our array of integers. Now our update integer method, its parameter list right here looks a little different than what we're used to, but it's not really that much different. It's just saying, oh, I expect a parameter named AR. What data type is it? Oh, it's an array of integers. So that's why it's got that the square brackets on it. Now, when that call happens, we call our update int method, that array's memory location is going to be passed to our update int method. So any changes that it does to our array would be reflected when our main continued on, because that array was passed by reference. We passed that memory location to it. So they're working on the same version. Questions about that? Does that make sense? They're working on that same spot in memory. We can, of course, tell C# to pass other variables by reference if we use that ref keyword. You've probably seen a little bit about that in chapter 4. And that's just us having the ability to override the passing by value to pass something by reference. But it always happens by default with entire arrays. Now, like we were talking about a little bit, arrays are actually a C# class. So anytime we create an array, we're creating an instance of the C# array class. It's derived of the system class in C#. So that means that it has access to all the properties and methods, like .length and other things like .sort that are available to arrays. So we could say that we wanted to use the sort method. We wanted to reverse the order of an array. We wanted to get a certain value. So we have a lot of different syntax options that we can use with the array class. So our arrays, of course, are super important, letting us manipulate repeating data elements efficiently. We can use them a lot with loops. We'll see that a lot. The for each statement lets us process all of the entries in an array really easily. And you guys want to create some practice programs to work with different data types and values and conditions and all those great things. So let's create, you guys already have a good one. I have a special puzzle for you for lab time here. I want to see if it'll work for you guys, if you'll try it with me. If you would go to File Explorer and go to the S drive. CIS150, and then under course data, this Japanese IQ test river crossing, drag that to your desktop. And then if you would, open it for me. Oops, I already have it open, hang on.
I don't have access to my student drive.
What's it do?
It's a it says a phone access. It might be because I'm a student. I always
Right click and access it.
The problem is that I can't access it. My student account very well either.
I'll let you email
Like,
it
I
to you.
can't
Hang
even
on.
use my email on there, so I always use my email.
I'll try to email it to you. Hang on, let
Sorry
me
about
show
that.
everybody. That's all right. It's just always,
I wish they would just merge the accounts. It would be so much
I know, I
easier.
do too. Okay, so you guys, if you try to play, enable the content and then say, I recognize the content, allow it to play.
Yeah.
We're gonna have a fun time here. Now, this is a logic game. So this game is kind of one like they are known to do in different job interviews. They have some nice example descriptions for you here. They give you, it's kind of frustrating to me that they've got all these nice English instructions now. I like it when it was all Japanese, then it was really a problem-solving issue. But we have a boat here. See if it'll play for you. It was always, you know, just one of those kind of languages that died. So here we have all these people that need to get to the other side of the river. The raft can hold 2 people. Children cannot go on the raft by themselves. They have to have an adult. We can't leave this criminal behind with anybody because he will whoop up on them. He can only be left behind with the cop. So the cop has to be there watching him. Now, in the same way, we have some family issues. The dad cannot be left alone with the girl children, and the mom cannot be left alone with the boy children. So now somebody has to drive the raft back. So it's not going to go by itself. So like I could do the dad and this son, is that going to be a problem? You bet, because I'm trying to leave that one boy alone with the mom. She's not trustworthy. So I have to figure out in a logical way how to get everybody across the river to see if they can get over there. So logic problem. So let's see how long it takes you to get it.
Mine doesn't.
See if it can't find you to email you, it should be able to find you to email you. There you are.
Yeah, I have such a problem with it.
There's no way to use it.
Well, I've tried to use it before, and for whatever reason, every time I try to use it, I can't use my email at all, so.
Yeah, they just have it set up to so click enable editing. Yeah, they have it on all my.
Oh, you need someone on the boat.
Yeah.
Remember, oh yeah, that's why I don't use the other day.
No, Kevin, adult on the boat. But the father on the boat. Take a look off. Oh my God.
Figured it out. Yeah.
That's the question. I don't know who the heck is on this.
It was like you did. We have one that's already shown y'all how it should be done.
not gonna roll with any members of the family. Let's fully protect the boat. Now bringing the boy over. No, policeman. Policeman and son. Now. Yeah, you can't have any of the kids, you gotta bring one of the adults over. So how am I supposed to?
I find it highly amusing that you can leave the children alone on the far end of the river.
Yep, just as long as they're not with the wrong parent.
Meow, meow.
As long as they got someone there.
Can't do that. Can't do that. Go back. No, you're not. You have to return to your mother.
Average time to eat is 15 minutes.
You're not done, dude. You're so close to figuring this out. Take the mother back. And the father back. Take the mother and father back. Take the mother and father back. Yeah.
I caught myself in a loop. Can't figure out how I can.
It's kind of like the code. You have to find the most specific thing and start with that and end with that. The most specific requirement.
Spanish.